Exponential equations. These are tricky because we have to be smart about our exponents. We have to really understand how the bases and how the exponents work together. And we really have to understand how those rules, those laws of exponents work. So let's look at a few quick examples here. An example question would say, find the value of x in this exponential equation. And an exponential equation is just any equation where the variable is in the exponent. So like here, this little x is in the exponent. The first thing I want to do here, if I can, is make both of these bases the same. I want to use what I know about exponents to force both of these bases to be the same. So I notice that these are kind of both multiples of 4, 16 and 64. So what I'm going to do is I'm going to, instead of 16, I'm going to write this as 4 squared, and the x, I'm just going to bring that down. So this is really still the same number, right? 4 times 4, or 4 squared, is 16. 4 squared is 16. So I'm just kind of rewriting this in a different way, and I'll show you why. 64, I can write that as 4 to the third power, which just means 4 times 4 times 4. Of course, 4 times 4 is 16, and then 16 times 4 is 64. So I'm just rewriting that. It's still the same number. I'm just rewriting it in a different way so it has the same base. So what I can do now that I've rewritten this, I notice that I have a power to a power. So this is 4 to the 2 to the x power. When I raise a power to a power, that just means multiply them. So this is going to be 4 to the 2x equals 4 to the third. So what I've done now that I've forced both of these to have the same base, 4 and 4, I can really just ignore the bases. I could ignore these 4s, and I can just look at the exponents. So bringing these down, I'm going to have 2x equals 3. So I'm ignoring the bases since they're the same, and I'm just bringing down those exponents. My final step here is to solve for x. I would divide out the 2. So divide this by 2, divide this by 2. I'm going to end up with a fraction on this one. X is going to equal 3 halves, 3 over 2. Let's look at another one. So this again says find the value of x in the exponential equation. These already have the same base. This is base 2 and this is base 2. So just like before, I can really just ignore the bases and bring down those exponents. So I'm going to bring down the 2x plus 2. I'm going to bring down the 3x. And now I can just solve this like a normal equation. I would start by combining my like terms. So subtract 2x from both sides, minus 2x minus 2x. That's going to give me 2 equals x, or you could say 1x. Just like that, simple. Let's try one more. All right, this one a little bit harder. So again, I just have to be smart about my laws of exponents. So first of all, I noticed I have, these are the same base 10 and base 10. And when I multiply, remember that I add exponents when I multiply. So instead of this, I can just multiply these 10 and add the exponents, negative 3x plus x. On the right hand side, so 1 over 10, this one I can actually write as 10 to the negative 1 power. And that's the same thing as 1 over 10. Remember, these negative exponents, they flip your fraction. All right, so let's see what we have here. Negative 3x plus x, that's going to give me negative 2x. And then let's just bring this down, 10 to the negative 1. So again, I've got the same base here, base 10, base 10. What I can do is, again, just ignore these bases and bring down the exponents. So I'm just looking at negative 2x equals negative 1. All right. My last step here is just going to be divide both sides by -2. And these are both negatives, -1 and -2. So when I divide that negative divided by negative, it's going to be positive, a positive 1/2. All right, so that's pretty much it. Again, these are definitely very difficult. The best way to do it is just to really understand your rules of exponents and try to see what you notice, see what patterns you notice in an equation, and try to figure out how can we make both sides of that equation have the same base.